Hi everyone, it's Mrs. Griffin with the Unit 5 Lesson 8 video. We're going to talk about dilations and how to use our compasses and straight edges to do a dilation. So for starters, let's talk about what that is. A dilation is a transformation, and it's where a figure is enlarged or reduced. So it's not a rigid motion, but it is a transformation. And it's enlarged or reduced through a specific point called the center of dilation. When we do the notation, it's a capital D, and then the lowercase or the subscript, the first thing is going to be the center of dilation, that point, and then there will be a number, and here we call it R, and that number is the scale factor. It's the multiple. The scale factor, like I said, is R, is the ratio of the length of the side of the image to the corresponding length in the preimage. So you're going to pick a side from the image, and you're going to put it over the side in the preimage, and then you divide, and that'll tell you how much bigger or smaller the image is compared to the preimage. If your scale factor is 1, then the segments are congruent. These are actually congruent triangles or shapes. If your scale factor is not 1, then your segments are going to end up parallel, or they'll be on the same line if you're dilating through a center that's on the original line, and we'll show you that. Okay. If the number for your scale factor is between 0 and 1, so it's a fraction or a decimal, then the figure is going to get smaller. It's going to move closer to the center of dilation. And if it's bigger than 1, it's going to get enlarged. So think about it. If I tell you that we're going to scale something by 1/2, which is between 0 and 1, it's going to be half of the original size. If I tell you it's going to be the scale factor of 2, then it's going to be twice the original size. It's going to get bigger and further away from the center. Okay. Scale drawings are similar figures where you're using a dilation and then also a rigid motion, possibly. So in those, because it is similarity, scale drawings are basically just similar figures, your angles are going to end up congruent and your corresponding sides are going to end up proportional. So let's do some practice with our constructions. So if you read your notation, it says that we are going to do a dilation, capital D. The center of dilation is going to be B. So that means B is going to remain fixed. You don't move your center. And then 2 here is your scale factor. So that tells me that everything is going to be twice the distance from point B. So what we're going to do is, starting with our compass at point B, we're going to open to point A, because AC is the segment that we are going to dilate. So we're going to open from point B to point A, and we're going to swing the arc to show that we measured it. And then we're going to move our compass and do a second arc. And this point where that second arc meets the original line is point A prime, the image of point A. It's twice the distance away from B that point A was. Now we're going to do point C the same way. So we're going to go to point B with our compass, and we are going to open our compass as wide as it takes to get to point C, swing the arc, and then we're going to move to that arc and repeat a second one. And this will be point C prime, and it's twice as far away from point B, the center, as the original C was. So where our original AC went from here to here, our new A prime C prime will go from here to here, and it will be twice as long centered at point B. So notice the image of the line segment was another line segment, and since the center of dilation was on the original line, the AC and its image A prime C prime coincide. Number 2. So we're going to dilate triangle ABC from point O, so this is going to be our center of dilation, and it's going to remain fixed, and this time we're still going to use a scale factor of 2. But notice what happens this time. The center of dilation is not on the original triangle. It's not in the same part of the figure that it was last time. So what we have to do is we have to extend a line from the center of dilation through each of these endpoints here that we're going to move. So we're going to take our line tool, and we're going to take point O and go from point O to C and beyond it, from point O to A and beyond it, and the same thing from point O to B. And what we're going to do is we're going to measure our scale factor of 2 for each one of these. So we're going to take our compass, we're going to put it on O, and do each one. So we're going to go from O to A, swing that arc, and then go along the same line and swing that, and this will be A prime. Next, we're going to take our compass and put the point on O and go from O to B. Swing the arc and repeat it down the line from here, and this will be B prime. Then we'll go from O to C, same exact idea as before. Measure from O to C and then slide down the line, and this will be C prime. And then all we have to do is connect them to make triangle A prime, B prime, C prime, our new triangle. Notice we're getting a similar triangle from what we started with. So notice that we got a triangle again, and that all A prime, C prime is parallel to AC, BC and B prime, C prime are parallel, and AB and AB prime are parallel as well. Going on to number 3. We're doing the same concept here. We're starting with a ray. We're going to end with another ray. This time, though, our scale factor is 3. So we are going to begin from our center of dilation O, going through J, and going through K, making lines that extend past both. And then just like before, we're going to put the compass point on O and open all the way out to J. Swing there, and then we're going to make 3. So 1, 2, 3, because our scale factor is 3, and that's point J prime. We're going to do the same thing from O to K and do 3 of them. So 1, 2, 3, and this will be K prime. And finally we'll connect them and make another ray from J prime to K prime. And make sure if it was a ray in the beginning, it is a ray again. This arrow is a little hard to see, so I'll make it a little bigger. Very good. Next is number 4. We're going to dilate AC, so this whole line, we're going to get another line, through point P using a scale factor of 1/2. So now, because it's 1/2, when we connect point P, we can pick any 2 of these 3 points, because it's any 2 of them will make a line. It's going to end up closer to point P. It's going to be half of the original distance. So I don't need to go past A or C because I'm going to do half distances, meaning I'm going to get closer. So I'm going to put my compass on point P, and I'm going to open more than halfway to A, because the easiest way to do half is to create a perpendicular bisector. And I'm going to do a perpendicular bisector from point P to A, and then I'll flip it around from point A to P. And when I draw that line in there, that line will be the perpendicular bisector. And so now this point here is going to be A prime. Remember, point P is the center of dilation, so it's remaining fixed. We're going to do the same exact thing for point C to get halfway to P. We're going to do a perpendicular bisector, so open more than halfway between C and P, and then flip it around. Go to point P and do the same arc so that we get 2 intersections, and then again you'll get a perpendicular bisector, so you will find the midpoint. So we'll do another one here, and this point where they are intersecting will be point C prime. And then when you connect them together, you will get A prime, C prime, which will be the line, which is the image of AC, and it should be parallel to it in another line. On to number 5. We're going to do the same kind of thing. We're dilating from point A, so point A is going to remain fixed, and the scale factor will be 1/2. So again, we're going to create a perpendicular bisector. So we're going more than halfway between A and B, and more than halfway again back the other way. And then this perpendicular bisector will intersect that line. And that will be point B prime, because remember, point A is remaining fixed. It's not moving. Now for point C, we'll do the same thing, more than halfway, and create a perpendicular bisector. And then we will find point C prime from there. So this will be point C prime right here. And then when we connect, this here is actually going to be our triangle, because A prime and A are going to be coinciding. They're going to be the same. So we have a new triangle on the inside here. I'm going to highlight it. And so here is a scale drawing, half of the triangle ABC. And so the image of a triangle is a triangle. On to number 6. Now this time we don't have a center of dilation, and we don't have a scale factor. So instead, remember that scale drawings are similar figures. So what we can do is instead, we can do angle-angle similarity, and we can copy the angles. So we have to remember how to do that with a compass. So to copy, we're going to start with angle A since we know where A prime is, and you're going to open your compass so that it will cross the angle in 2 spots. So it will go here to here, and we'll do the same thing over here on A prime. And then what we need to do is measure that. Remember to swing the arc that shows you measured it, and then you're repeating that over here. And then you'll connect that from point A, point A prime, since that's what it's the image of, and just go beyond because you don't know exactly how long it needs to be. We're going to do the exact same thing from C now, since we know where C prime is. So we'll cross through angle C twice. We'll repeat that same size arc at C prime, and then we will measure how wide open that angle is from intersection of the arc to intersection. We'll swing the arc to show we made that measurement, and we'll repeat it over here. And then we'll draw the line from C prime, since that's what we were measuring, all the way through. And then where these two cross has to be B prime right here. And our triangle is now similar. Number 7, we're going to dilate the circle again with a scale factor of 1/2. So just like the previous ones, we're going to connect from point O, which is my center of dilation. And since it's half, I'm getting closer to point O, so I don't need to go beyond the points. And we're going to do a perpendicular bisector for both. So we're going to take our compass, we're going to put it on point O, and we're going to go more than halfway between O and C. And we're going to make ourselves a perpendicular bisector from O and C. And then when we connect that line, where it crosses OC is going to be C prime. And we're going to do the same thing again between O and A, where we do a perpendicular bisector. So we open our compass more than halfway between O and A and swing our arcs. And then draw in the perpendicular bisector. And where that meets OA will be our point A prime. Then, since we started with a circle, we have to end with a circle. So we're going to put our compass between C prime and A prime and make this circle. And this circle will be similar to the original. And so a couple key points. The image of a circle is a circle, and all circles are similar to one another because of this. Alright, next we have to find a center of dilation. This is actually much easier. You don't even need a compass. All you need is your straight edge. To find the center of dilation, all you have to do is connect an image and a pre-image and figure out where this crosses for all of the different points. And so if you're connecting with your ruler, B to B prime, A to A prime, and C to C prime, you're going to see that they all intersect here at this point, and this point is your center of dilation right there. Now it does also ask for the scale factor, but since there's no numbers here, remember that we can represent the scale factor using the letters. So we would take a side from the image, like A prime, B prime, and we would just put the name of it under the corresponding side from the original, A prime. And so that's the scale factor. On to number 9. A very similar situation, we're doing a center of dilation, so we're connecting A prime to A, B prime to B, and C prime to C, and we're seeing where those points all where those lines all intersect. And you can see here is your center of dilation. And again, the scale factor, you would only need to take your names. So you would take your name of a side, any side you would like. For example, A prime, C prime from your image, and you would put it over the corresponding side from the pre-image, like AC. Okay. Notice on this one that the center of dilation is between those, and if you look, you're actually seeing that the shape almost looks like it's turned in addition to being dilated. That's called a point reflection, if you can remember. All right, I will see you in class.